So hello and welcome back. So in the previous video we had basically we were working on some problem, and we ended up with basically we had two companies, and one of the companies, it's the type of the business that they did could be modeled by this function b of x is equal to 100 times 1.5 raised to the power x. And basically there are two terms here that need to be explained. I did not explain them in the previous video properly. So first of all, when you have a function like this, b of x is equal to 100 times 1.5 raised to the power x, it's the kind of basically this, this, as you know, is your initial value. So this is your initial value, and this is your growth factor. So this is called your growth factor. And where they basically come from is that, for example, this company, if you have a table for that, and if this is your x and this is your b of x, the input of your function and the output, what happens here is that first of all, when your x is equal to 0, when your x is equal to 0, there is something wrong here with this program. Okay, when your x is equal to 0, you basically, anything raised to the 0th power is equal to 1. So 1.5 raised to the power 0 becomes 1, and then you end up with basically 1 times 100, which is equal to 100. So that's basically why it's called your initial value, and that's basically also the y-intercept of the function. Now every time basically you add 1 unit to your input, to your x, let's say from 0 you go to 1, for example, 1 year, 2 years, 3 years, and so on and so forth, you're adding 1 to your input. Again, adding 1 to your input. So as you add one unit to your input, basically this keeps increasing. That means that now this output is going to be 100 times one of these factors, one of these growth factors, so times 1.5. And again, times, basically when your x is equal to 2, it becomes 1.5 raised to the second power, which becomes 100 times 1.5 raised to the second power. So this is the first power, and this is 100 times 1.5 raised to the third power. So every time and this basically means that 100 times 1.5. This means 100 times 1.5 times 1.5. This means 100 times 1.5 times 1.5 times 1.5. So as you keep increasing your input, the number of times that this growth factor is being multiplied by the initial value of the function is basically increasing, basically 1 by 1. Here you have 1 time, twice, and thrice. So what that means is that when you multiply 1.5 into any number, whatever that might be, you are increasing that number by 50%. For example, let's see, for example, if you have 100, so you know that basically 50% of 100 is 50. So if you increase 100 by 50%, that means you're taking your 100, you're keeping the 100 and add 50 to it. So plus 50%, so that means you have 100 plus 50, which becomes 150. Now, basically you are and you can write this as 100 plus 50% of 100, and this becomes 100 plus 50% of 100 is 50, and this becomes again 150 here. So and you can rewrite this again in the following way, which is basically 50% of 100. You can write it as 100 plus 50% of 100 becomes 50 divided by 100 into 100. And so these two cancel out, and this becomes basically 150. Of course, this is not the way I wanted this to turn out. What I wanted to do was that I wanted to rewrite this as 100 plus, you can write 50% in decimal form as 0.5. 0.5 into 100. So now you can simplify this. You can take 100 out. So 100 times 100 divided by 100 is equal to 1, and 100 divided by this whole thing becomes 0.5. And so this becomes 100 times 1.5. 1.5. So that basically means that whenever you're adding 50%, for example, 200, you multiply your 100 by 1.5. If you're adding 60% to the 100, you multiply your 100 by 1.6. If you're adding 6%, so this is adding or increasing by 50%. So this is again adding or increasing by 60%. If you want to increase your 100 by 6%, you simply multiply 100 into 1.06. That becomes 6%. So that's basically all about this whole business here that we had. And so then in that, for example, in this number 1.5, you have a, as you saw, we had a 1 plus 0.5, which became 1.5. And so in this 1.5, we have basically a growth rate, which is this number, a growth rate, and this 1.5 is called the growth factor. For example, when they say that in some word problems, you might read, for example, a culture of bacteria is growing, the number of the bacteria is growing by a growth factor of 1.5 or by a growth factor of 2.6 or something like that. That's basically this number that you eventually can multiply by the basically initial value of the function, and every time you increase the input, then that growth factor is being multiplied by the output more and more times to give you the final output of your function. So that's basically what I wanted to discuss here about the previous problem, and these are important points to understand about about increasing something. And also, now that we have time, we can also talk about decay. So this was all about growth. You see that I wanted to increasing anything by, for example, 50%, I multiply that by 1.5. What about if you want to, for example, decrease something by 40%? What do you do then? So decreasing something by 40%, so here basically decreasing by 40%, what you need to do is basically, suppose that you have 100 and you want to decrease it by 40%. That means 100 minus 40% of the 100 that you had. So you can rewrite this as 100 minus 40% is the same thing as 0.4 times 100. And then you can take 100 out here, times 1 minus 0.4. So this becomes 1 minus 0.4 is 0.6. So this becomes 100 times 0.6. So whenever I multiply 100, for example, any number is possible, of course. When I multiply 100 by 0.6, that means I am decreasing it, or decreasing by basically 40%. If I multiply 100 by, for example, 0.3, I'm decreasing it by 70%. If I'm multiplying, basically you just need to add them up, because 0.3 plus 70%, which is 0.7, is equal to 1. Again, 0.6 plus 40%, which is 0.4, is equal to 1 again, and 1 represents 100%. So that's basically. And you can of course use your own logic and do any combination of all of these things. Whatever works for you in a certain situation, you can come up with some way to express it mathematically. So that's basically the whole idea here. But what we use in these exponential functions, that's basically the basic things that you need to know. So I'll see you in the next video.